beautiful thing about stoichiometry is that I am not going to teach you a darn thing that you don't already know. We're just going to be putting together everything we've learned from this chapter so far into kind of one larger dimensional analysis problem, one bigger conversion factor. And the only thing we're going to look at here is how can we read this chart? And we've got a couple different charts there's a different one on the back of your periodic table, but it's very similar to this. So we're just going to look at how to read it. This is what we call the mole map. If you look at it, it has a couple different parts, and they all represent conversions. If you have moles of a substance, we can convert to molecules using Avogadro's number. That was one of our first podcasts. If we have moles of a substance, we can also convert to grams using the molar mass. That was our second podcast. We can also go moles, molecules, and atoms. Those are the same thing, first podcast. And then if we have moles of one substance in a balanced equation, we can do moles of another substance. That was our third set, the molar ratio. So I've got Avogadro's number, molar mass, and the molar ratio, and I can use all three of those things to kind of set up a larger dimensional analysis problem, and that is what we call stoichiometry. Let's take a look. All right, here's my balanced equation up top, and here's my mole map, or my mole maze. If I have 23 grams of calcium, how many moles of calcium do I have? This is review. 23 grams of calcium. How can I convert from grams to moles? Well, if I look over here on my maze, grams to moles, I can do it in one step using the molar mass. If I look up the molar mass of calcium, I know that for every 40.08 grams of calcium, I have 1 mole of calcium. Grams cancel out, and I just got that right off the periodic table. Grams cancel out, I divide 23 by 40.08. I have 2 significant figures, and my answer comes out to be 0.57 moles of calcium, which makes sense. 23 is a little bit more than half of 40, so I have a little bit more than half of a mole of calcium if I have 23 grams. But let's say I didn't want to stop there. Let's say if I had 23 grams of calcium, I wanted to convert to atoms of calcium. How many atoms, individual calcium atoms, are there in 23 grams? Well, I can figure that out with my mole maze. I need to go, there we go, there's the eraser. If I want to go from grams, start here, and I want to go to atoms over here, I can do it in 2 steps. First step is convert from grams to moles using the molar mass, and then from moles I can convert to atoms using Avogadro's number. So step 1, let's say I had 23 grams of calcium. I need to convert it to moles, because that's my central location. Kind of everything in chemistry gets converted to moles at some point. 23 grams of calcium, same first step I did before. 40.08 grams of calcium is 1 mole off the periodic table. Grams of calcium cancel out. But now instead of stopping, just like we did with dimensional analysis, I'm going to set up another chart, and I'm going to convert from moles to atoms. And I remember Avogadro's number, that 1 mole of calcium is going to equal 6.02 times 10 to the 23rd atoms of calcium. Moles of calcium cancel out, and I just set this up in 2 steps, and now this is a stoichiometry problem. And my answer, still with 2 significant figures, 2 sig figs, 2 SF, gives me 3.5 times 10 to the 23rd atoms of calcium. That's how many individual atoms there are in 23 grams of calcium. So I just used my maze to set up a problem in 2 steps instead of stopping at 1. Everything we've done so far is just kind of a 1-step process. Molar mass, molar ratios, and Avogadro's number. Now we're going to put them all together. Let's do another one. Let's say I had 4.61 moles of H2O2, that's hydrogen peroxide, and I want to know how many grams of oxygen I can get. Okay? This is the reaction that happens when you put hydrogen peroxide on a wound. It bubbles, you get oxygen gas that comes off, and it forms water in your wound, and it cleans it. So what do? I have moles of hydrogen peroxide. So right here, moles of hydrogen peroxide, H2O2. But now I'm talking about oxygen with it, which is different. So I'm going to label these A and B because they're different substances. The only way I can go from A to B is using the balanced equation. Okay? That only takes me to moles of B though. So let's do that first. 4.61 moles of hydrogen peroxide. There's my chart. And using the balanced equation, I know that for every 2 moles of H2O2, that needs to go on the bottom, and I'm trying to get to oxygen, there's 1 mole of oxygen, O2. And those are just the coefficients. That's a molar ratio. Okay? Moles of hydrogen peroxide cancel out, and I'm left with moles of oxygen. Well, I want grams of oxygen, so I'm down here. Well, if I have moles, I can go to grams as well. Just like up here, if I go moles of A to grams of A, I can go moles of B to grams of B. Moles to grams is a really easy conversion. That's the molar mass that we've been doing. So if I have moles of oxygen, and I know the molar mass, I can say that 1 mole of oxygen is going to be equal to the mass of 2 oxygens. So each one is 16 on the periodic table. 2 of those is 32 grams of O2. Moles of oxygen cancel out, and I have grams of oxygen as my final answer. I multiply this all out, and I get an answer with 3 significant figures, because that's what I started with. So you always look at what you start with. 3 significant figures is 73.8 grams of oxygen. This is a very common conversion. Okay, moles of one substance to grams of another. All right, let's put it together a little bit more. And stoichiometry is really useful because we don't really measure out moles of a substance. We measure out grams when we're doing a reaction. So it's really useful to convert from grams to one substance to grams of another. For instance, here's my equation. Single replacement reaction. If I measure out 41.9 grams of sodium, I want to know how many grams of oxygen I can produce. It's useful information if you're in a lab. So grams of one substance to grams of another. So if I'm up here at grams, my first step, according to my map, is to convert to moles. And then where can I go? Well, they're 2 different substances, so I'm going to label them A and B. The only way to go from A to B is moles to moles, so I need to use my balanced equation, 2. And then if I have moles, I can, again, I'm going to kind of create another box down here. I can go back to grams of that substance. This is probably the most common type of conversion you're going to do, grams of one substance to grams of another. And it's one of the longest ones that we're going to do. So pay attention to this one. Ask questions if you don't see what we're doing. Starting out with grams of sodium. All right. If I have grams, I need to convert to moles. So I can look on the periodic table and see sodium weighs 22.99 grams for every mole. Grams of sodium are gone. Second step, is moles of one substance to moles of another. That's my ratio using the balanced equation. So 2 moles of sodium is going to be equal to 1 mole of copper. And this is sodium up here. So it's really important to write the symbols. I just forgot there. But that's going to help you with the molar ratio because you need to know that sodium goes on the bottom. 2 moles of sodium is 1 mole of copper. Moles of sodium cancel out, and I'm left with moles of copper. Trying to get to grams of copper. That's not too bad. I can do the molar mass again. I can look on the periodic table, and I know that for every 1 mole of copper, I get 63.55 grams of copper. Moles cancel out, and now I have a 3-step stoichiometry problem that I can multiply everything together. 3 significant figures. I get 57.9 grams of copper. All right. One of the most useful tools in chemistry is stoichiometry. We're going to be using it a lot the rest of the year. It's very useful in college. It's done all the time. So get some help with this one. This one is kind of difficult, but make sure you ask questions, review your notes, and good luck.